Hello everyone, welcome to the session. Just give me one moment, let's check I'm online. Okay, so welcome back to the session. So in today's class what we are going to do is we are going to, this is the continuation of error analysis. Part 1 we have already done, you can go check that video. So today in today's class what we will learn is about combinations of errors. Alright, so before we begin, my name is Mohana. I'm a physics educator here at Unacademy and I have my master's degree in physics and I'm also a plus verified educator. Now you can follow me through my Telegram channel, right? And this is the common Unacademy ICSE and ISE board channel as well. So you can follow both the channel. So let's begin today's session. So last class we were discussing about errors and very simple. Let me quickly start with what we discussed. So this is basically, if you, let's say you have the pencil and if you want to find what is the true value of, let's say this particular pencil has a particular value, right? Let's say I want to measure what's the thickness or the diameter of this particular pencil. So I could use a screw gauge and let's say the actual value is, for example, the actual value could be 150 centimeters, right, or millimeters. Or for example, even I can use a vernier caliper and let's say I'm getting up to two place values. Now, let's say I am doing the measurement and I get a value up to 1.13. What is the difference in this measurement? That is around 0.02, right? This basic value becomes your error. Okay, so error is nothing but the difference between, okay, error when you're measuring, error is nothing but the difference between true value, right? What is basically the actual value, right? True value minus what was the measurement, what is the value you measured, right? That will be the measured value. So this is basically gives you the idea of error. Now, last class we discussed about how to eliminate errors, especially how to find the true value, that is the mean value, and how to find, how to express errors in terms of relative errors and percentage errors, right? As well as in terms of absolute errors. We have seen each cases in depth, so you can see that video. This class what we are going to do is, in case whenever you do an experiment, there will always be a combination of a quantity that you're taking. For example, if you want to measure force, there are two quantities that is involved. First of all, you should measure mass and then you have to measure acceleration. Now, there could be an error while measuring mass and there could be an error while measuring acceleration as well. Now, when you have combinations like these, right, how do we eliminate the error? For that, we are going to see some rules. Now, the basic thing to keep in mind is whenever you're finding combination of errors, the rule will be you have to find what is the maximum possible error that particular system could have. Okay, that's one point to be noticed. Now, there are certain rules to evaluate the possible error in a measurement, okay, and always you're evaluating a maximum error. We're going to see each case. When there is a sum of two quantities, how do we measure error? For example, let's say we have two quantities. Let's say, for example, you have mass of one quantity, right? You're measuring mass of one quantity and you're measuring the mass of another quantity. Now, you're going to add this mass. So there might be an error when you measure the first quantity and there could be an error when you measure the second quantity. Now, how do we get the difference, how do we get the total error of this entire system? That will basically be sum of errors. Now, in case if you're finding the difference, when you're finding difference between the two quantities, what is the error? Product is nothing but when you're multiplying those two quantities, and division or quotient is what is the error in terms of division or quotient, or error in terms of power of a quantity. For example, when you have something like v square. Right? How do we find error in such a case? So this is what we are going to see each and every case in detail. Alright, so let's first begin. First thing what we are going to see is we are going to find when there is the sum of two quantities. As I told you the example earlier, let's say we are measuring mass of a quantity. For example, let's say I have to measure for a particular quantity. Let's say you are trying to mix two chemicals, and in this case you have to measure the chemicals up to a particular value, okay, accurate value. So you're measuring one part and you're measuring another part, right? M1 and M2, you're measuring two quantities. Now M1 could have an error, okay, which I can express as delta M1, and M2 can have an error which I can express as delta M2. For example, M1 could be 1 gram plus or minus 0.1. Okay, grams. This could be the error, plus or minus 0.1. So when you took M1, that particular quantity, it could be somewhere around 0.9 to 1.1. M2, similarly M2 could be somewhere around, let's say in this case you are taking 1.2 plus or minus 0. This could be somewhere the error is 0.2. Okay, so so in this case the error could be somewhere around 0.8 to 1 to, right, from 1 to the measured quantity could be somewhere around the range of 1 to 1.4. Right, now when you add these two quantities, see there is error term on both quantities. Now how do you find the total error? If you let's say M is nothing but M1 plus M2. Now how do you find the error in M? Okay, error in M we can represent as delta M. That is very simple. You can find it by adding delta M1 plus delta M2. Okay, if you find that, you find the the final error. Okay, so the delta M term that we have gotten everywhere here is nothing but the absolute error. So when you are actually measuring error when you are adding two quantities, what is the maximum possible error that sum of two quantities could have, that is the system could have, will be equal to sum of absolute error in the individual quantities. You find absolute error in individual quantities, add them together. So if you want to represent it in a more general form, you can take you can take the first quantity you're measuring instead of M1, the first quantity you're measuring as A, then that will be A plus or minus delta A. Again, measurement of B will be B plus or minus delta B. Sum is what? This is the final quantity is A plus B. So when you're finding the error in that will be nothing but delta Z. The error in Z is delta Z. Right, that is nothing but the error in A, that is delta A, plus the error in B. It will always be a positive term over here. Okay, very simple. Why? Because for a given system we are trying to find what is the maximum error. Okay, now let's do this with an example. We have two resistors, resistance R1 and R2, and they are connected in series. Okay, so let me give you a quick overview. You might done it in your grade 11, right? Let's say we have two resistors. This is R1, this is R2. Now if they are connected in series means one next to another, but that is basically if a current is flowing through it, same current, whatever is the current flowing through R1, same amount of current will flow through R2. Okay, now equivalent resistance is what? Instead of using these two resistance, if you use just one single resistance in that circuit, okay, which is equivalent to the same value, right? Instead of using R1 and R2, if you could use one resistor, what value would that be? That is basically your equivalent resistor. Okay, such that the same current should flow in this particular circuit again. Right, now if you want to find the resistors, here we have gotten a value in terms of the value plus error. So now we want to express this in terms of what is the final resistance, okay, plus their equivalent error as well. Okay, so very simple. Equivalent error in this case will be basically R1 plus R2. Okay, so so in this case, what is R1 over here? R1 over here is 15 plus R2 is 25. Right, that gives you somewhere around 40 ohms. This is basically the equivalent resistance. Now you want to find what is the error in equivalent resistance, delta, the error, absolute error in equivalent resistance. That's given over here. That error is given over here. That is nothing but 0.3 plus 0.4. which is nothing but 0.7 ohms. So if you see 40 plus or minus 0.7 ohms is the total error we can see. So instead of these two, if you're using one single resistor, that 40 ohm resistor that you're using, right, and equivalent resistance when you're finding, as a total system if you look at, if you look at, these two add up to 40 ohms, but their error value could be somewhere in the range of 0.7 ohms, which means the percentage 0.7 ohms, right, of value could be, it could be 40 minus 0.7 or 40 plus 0.7, right? That could be the range within which the final resistance is. Okay, this is error in terms of error in terms when you have to add two quantities, how we have to add errors. Very simple. In other words, in just one way, add the errors, that's it. Add the individual quantities, add the error, that's it. You get the final answer. Okay, now what will we do when we have to find error in, when you have to find combinations of errors, especially when there is a difference involved. For example, let's say, for example, okay, let's say we have a container, and in this container let's say we have 1 kg of rice, okay, or some quantity. Now we are removing certain percentage or certain quantity of it, let's say somewhere around let's say this is 2 kgs, and let's say we are removing around 0.5 kgs from here, okay, 0.5 kgs from here. Now when we are saying 2 kgs, there won't be exactly 2 kgs of quantity over here, right? It could be 2 kgs plus or minus, let's say there is an error of about 0.1, that is about nearly 100 grams error is there. Okay, and let's say in the second case, okay, we are removing 0.5 grams. We may not exactly remove 0.5 grams, maybe there could be an error of 0.005 grams. That is meaning you could leave out, you may not exactly remove 500 grams, you might have removed around 50 grams could be the error. That is, so you might have you might have lost some, you might have just removed 450 grams, okay, or you could have actually removed like 550 grams, right? Now how do we find what is the maximum error in this particular case, right? Very simple. When you're trying to find maximum error in case of subtraction, all you have to do is add the errors again, okay, that's it. Very simple terms, okay, because you're trying to find what is maximum possible errors. So when you subtract two quantities, let's being z being the difference, this is not the sum, I'm sorry, this would be the z, consider the difference, right? The difference being a minus b, right? In this case, what we generally notice is in the errors, if you subtract them, then it might actually look as if there is no errors, right? But what we saw, there is a particular possible error that is actually applicable in this case as well, right? So whenever you're doing error analysis, even if there is a difference that you have to find, you have to add the error terms, okay? So the maximum possible error in a difference of two quantities is equal to sum of absolute errors in the individual quantities. Okay, find the individual absolute errors in individual quantity, add them together. That will give you what is the maximum error in the final quantity. Okay, now very simple. There is a quick question that is asked. The liquid in a container is heated. The initial and final temperatures are given. Okay, initially the temperature was 23 plus or minus 0.2 degrees Celsius. Final temperature is 50 plus or minus 0.7 degrees Celsius. We want to find what is the rise in temperature. Okay. So, very simple question over here. What they are asking us to find is to find what is the rise in temperature. Okay, we have to find it with the errors. So, in this case, what we would end up doing is very simple, that we would see rise in error. Okay, that is the final temperature, or we'll take this as rise in error, rise in temperature. No, let's call this as the temperature difference that we are actually trying to find. Okay, this is basically nothing but the rise in temperature will be what? The rise in temperature will be nothing but what was the final temperature? Okay, so let's write final temperature as TF minus what of the initial temperature. So if we find the difference between these two quantities, you will find how much temperature, when you heated this particular liquid, how much there was an increase in temperature. Right, what is the final temperature over here? 50 plus or minus 0.7 degrees Celsius. Right, minus what is the initial temperature over here? Initial temperature is very simple. That is nothing but 23 plus or minus 0.2 degrees Celsius. Now first thing you're going to do is you're going to subtract these two quantities from here. Very simple, you have to do 50 minus 23, that gives you somewhere as the difference of, because you're trying to find the you're trying to subtract, right? So you have to do 50 minus 23, okay, plus or minus. Now comes the error part, that is the error part over here. Error part, we are trying to find what is the maximum possible error. So you should always add those terms together. Okay, error part, you should always add them together. Okay, because we are trying to find in this particular system what is the maximum error possible. So 50 minus 23 is 27 plus or minus 0.7 plus 0.2. This is 0.9. This will be degrees Celsius. So answer is over here is D. Alright, okay. Now let's go to the next quantity. Next, what we want to find is when you're multiplying two quantities. For example, you're multiplying force is equal to momentum is equal to mass into velocity. Now, what could be the possible error? Because there could be an error in momentum, right? There could be an error in velocity. When you're measuring the velocity, there could be an error. When you're measuring mass, there could be an error. So finally, when you're expressing your answer as momentum, okay, these two errors will basically contribute towards the error in momentum. How do we do that in case when we are actually having multiplication? So now addition and subtraction, we made use of absolute error. Okay, this case we are going to make use of fractional error. Okay, so once again, the previous class recordings, okay, part 1 of the series has basically the error analysis part 1, right? The previous class video has we have discussed in details about all types of errors, so you can go through that. Okay, so in this case, what we are saying is the maximum fractional error, okay, is the product of two quantities is equal to sum of fractional error in the individual quantity. Because there's multiplication, now what we are going to find is fractional error. Fractional error is nothing but what is absolute error, right? This is nothing but absolute error, mean absolute error by a mean value, right? Mean value, or this is basically gives you the fractional error. Okay, so so once again, in this case, we are trying to find what is the maximum error possible. Very simple. Okay, let me give it with an example itself. Momentum using mass into velocity means mass, you could measure mass of this particular quantity. For example, let's say a car is going by and the car weighs around approximately 150 kgs. Okay, for example, okay, I'm going with a bigger number again, 150 plus or minus, okay, let's say around 10 kgs. Okay, so this is the error in mass, right? Delta m. Now, what is the error in velocity? Let's say the car is going at a speed of, let's say the car is going at the speed of, right, the car tends to go at a speed of velocity, let's say around 50, okay, plus or minus, give or take 2 meters per second is taken, right? So, here, this is V, this is error in the value, delta V. Okay, now, what do we want to find? Momentum. Momentum is very simple, mass times velocity. Okay, till here this is the general form of writing it, right? So let's say mass is basically A, so that is A is equal to A plus delta A. B let's say is velocity is being B plus delta B plus or minus delta B. Z is what? M into V. M into V, in this case we are doing A into B, right? That's it. We have given in the general case. Now, what is the error in delta Z? In momentum, what is the error? Okay, momentum, what is the error? How would you represent that? Which will be P, right? P, in this case it will be plus or minus delta P, right? Very simple. To find the error, this case you have to find in terms of fractional error. This value we have over here is the mean actual value, and this value is actually the absolute error. Okay, now you have to take, that is similar in each case. Alright, now you have to take what is delta P over here, that is basically your absolute error by the mean error. Okay, mean value. In each case you have to do that. So if you actually want to find what is the error in momentum, that is nothing but delta P by P. Okay, this is fractional error in momentum. This is basically equal to what is the fractional error in mass, that is delta M by M, plus what is the fractional error in velocity, delta V by V. So you find the fractional error, add them together, you will get what is the final fractional error in terms of momentum over here. Okay, so for this case, let's see, we have an example, so let's try doing that. Okay, delta P by P is equal to what is delta M by M? Delta M by M is nothing but 10 divided by 150, right? Plus delta V by, in this case it is, in this case delta V by V. Delta V by V is 5 divided by 50, right? So let's see what is the value. Let me quickly make use of this case over here. Okay, so in this case, if you want to see delta P by P, this is going to be very simple. All we have to do is 10 divided by 150. Let's say I will round off this value to somewhere around 0.066 it would go on, so I'll round it off to 7, okay, approximately. Next is 2 divided by 50, this will give me somewhere around 0.04. So if I add these two values, I would basically get 0.07 plus 0.04, right? I'll get 0.11. Now what we want to find? Momentum, right? Momentum is nothing but mass times velocity, right? So error is 0.01. So how do we write the final answer in this case, right? How do we write the final answer? So momentum is nothing but mass times velocity. What was the mass we took? 150. What was velocity we took? 50 meters per second, right? 150 times 50 is nothing but 7,500. This is P. Delta P we found it to be 0.11. So final answer, that is, what is the error in momentum is 0.01. How do we express this answer? P plus delta P, right? This is absolute error. Delta P by P is what we found, okay? P plus delta P by P, that is the fractional error, okay, is nothing but 7,500, okay, plus or minus 0.11. This would be around the order of unit will be kilogram meter per second. Okay, here what we are finding is fractional error. Okay, now that way, so one example, let's actually do one more example as well. Alright, now the edge of the edge length, okay, of a cube block of wood, okay, is measured to be L is equal to length is equal to 14.24 plus or minus 0.04 centimeters. This is error. This is in terms of absolute error. Okay, we have to determine what is the percentage error in the volume of the block. Very simple. What we want to determine is what is the percentage error in volume of the block, right? So here what we know, what are the known quantities we have over here? We know what is the length, right? It's a cube, so this side length is given. Same length will be on this side and also on this side, right? All these three sides will have the same length because it's a cube. What is volume of a cube? Volume of a cube, if you see, is nothing but L cube. Or in other words, we can write this as, okay, we can write it as L into L, right? What they are asking us to find is what is the percentage error in the volume of the cube. That is, they are asking us to find what is delta V by V, right, into 100%. Delta V by V is basically a fractional error, okay, into 100% gives you percentage error. Okay, so from here we have something around okay, so let's do this. Let's try and do this over here. Okay, so what we want to find is basically delta V by V into 100%, right? So V is equal to length into all side lengths, L cube, right? So over here, first we have to find what is the length value over here, right? So L value over here is given as 14.24 plus or minus 0.04 over here, right? That's the value that was given. Now from here, if you see, L will be nothing but this is L plus or minus delta L, right? So this quantity will be what? Delta L by L, right, into 100%. Similarly, we can do it for three other values, right? Plus delta L by L into 100%, right? Plus again we have delta L by L into 100%. What we will do is we will simply do delta L by L plus delta L by L plus delta L by L, and the final quantity will multiply by 100%. Okay, so very simple. What is delta L over here? This is delta L is 0.04, right? Divided by mean value, that is 14.24, right? So if you do 0.04, this again for all terms, again you have the same value, right? This will be the same value, right? All of this value we have to multiply by 100%, right? So if this value, if you see this value, if you divide by 14.24, right, you will, and add all the three terms, you will end up getting somewhere close to 0.0084, okay, into 100%. So multiply with percentage. The percentage error in terms of volume will be nothing but, okay, this moves to somewhere close to 8.1%, which is approximately equal to 8%. Okay, this is how you find percentage error with respect to volume. So here the answer tends to become 8%. Right, this will become 0.8%. Now one thing is, this is for a cube. If in case if it's a rectangle, it will be length into height into the breadth. Right, it will be very simple. So all three quantities could be given, same step can be followed. Now because we are using V is equal to L cube, this will be very easy if you are taking the power term over here to find the final answer. Okay, we can actually do this. We will discuss this case finally as well. Okay, now next quantity we are going to see is, what if when we divide, what do we do? When we have to divide two quantities, what do we do? So I'll quickly explain this. The maximum fractional error in a quotient of two quantities is equal to the sum of fractional errors in the individual quantities. Very simple. Okay, but what we are going to do, similar to the previous case, the main wherever you want to divide, for example, let's say force is equal to mass times acceleration. Acceleration is asked. Acceleration will be what? Force by mass. Very simple. You divide this quantity, but in each case, just like the previous quantity, find the fractional error. Okay, find the fractional error. Find the fractional error and then finally add the quantities. That will give you what is the error in basically acceleration, especially when you're dividing quantities. Okay, so let's see this with an example. Okay, now the resistance, okay, from Ohm's law we know V is equal to I into R. From there, R will be what? Nothing but potential difference by current, right? So where V is equal to 100 plus or minus 5 volts and I is equal to 10 plus or minus 2 amps is given. We want to find what is the error in terms of fractional error in R. Okay, what they are asking us to find is, with R, they are asking us to find delta R by R. Okay, delta R by R will be nothing but what is delta V by V plus delta A by the current, right? So let's not go with the units. The current being delta I by I. That's it. That's all you have to find fractional error over here. Okay, now very simple quantity. Over here, what is this 100? This will be V plus or minus delta V. This quantity is nothing but I plus or minus delta I. Right. So V is what? 5 divided by 100 plus current is what? In this case 0.2. That is the absolute error by the mean value, the actual value. This gives us fractional error, right? 5 divided by 100 is very simple. This is 0.05 plus 0.2 divided by 10, very simple quantity again, it will be 0.02. So what is the total fractional error? That is, in terms of resistance, what is the fractional error in resistance? That is 0.07. Okay, ohms. That is the error. I mean, again, that will be the again we are finding error, so we don't have to worry about the unit in this terms, right? This is basically 0.07. That is the fractional error. That amount of value would basically be, so that is the error in the that is basically the error in terms of fractional error in a resistance. So how do we find the resistance value over here? V by R, right? If you want to find the actual value, it is just V by I. V is basically 100 divided by 10. So resistance plus or minus, what is the error in resistance? If you see, this quantity will be nothing but 10 plus or minus 0.07 ohms. So in terms of fractional error, there is basically in 10 ohms, it could be around, right? It could be this could be in the range somewhere from 9.93 to 10.07 ohms. Okay, that will be the range in which the 10 ohm resistor would work. Okay, so this is when you're dividing two quantities. What if there is a power term? Okay, what would we do if there is a power term? So we took the example of previous case, no? V is equal to L cube, right? What will we do if there is a power term? Same process as earlier. Okay, what we would end up doing if there is a power term is this Z is nothing but a to the power of n. For example, the volume is equal to L cube, right? So this L will be nothing but what? Whatever is the actual length plus or minus the error in length. So what will be the error in volume in this case? If I am writing in general term over here, okay, let's say I am writing the general term over here. What is the error? Error will be So fractional error in the nth power of a quantity is n times the fractional error in that quantity, which means you find delta z by z, which is actually equal to, okay, what is this nth term? N times delta a by a. So if you're writing for volume, the previous case where we added all the three terms, instead of doing that, you can find what is the fractional error in volume, okay, for which you can just do 3 times delta L by L. Makes sense, right? We added delta L by L 3 times, so that is nothing but 3 times delta L by L. That's it. You can directly go with this one. Okay, so let's do a question based on it. Okay. If the length and time period of an oscillating pendulum has 2% and 1% respectively, we want to find what is the error in the estimation of G. Okay, so very simple question, and we know that the time period over here is actually, time period of a pendulum is actually given by 2 pi, right? This is actually given by 2 pi root of L by G. Right, they have given what is the error, percentage error for time period, right? Percentage error they have given for right, sorry, just a second, right, percentage error for length is being given as 2%, right? Now similarly they have given us what is the percentage error in terms of time period, right? They have given it as 1 in terms of time period. The percentage error is 1%. What do we need to find over here? We need to find what is the percentage error in G. This is the quantity we want to find. Okay, so that's very simple. All we have to do is we have to make sure first we have to write this equation so that we get G on this side and all of the quantities on the other side. G on one side and all of the quantities on the other side. For that, what we can do, we can square on both sides. So this side, if I square, again this will become 4 pi square. Then I'll have L by G. From here G is nothing but 4 pi square, okay, then this will end up becoming 4 pi square L by, this will again end up becoming 4 pi square L by T square, right? That's it, very simple. What they are asking us to find the error in the estimation of G, that is they are asking us to find, okay, error in the estimation of G, right? What is the percentage error in terms of G? This is what they are asking us to find. Right, percentage error in G is what is the absolute error in G by the actual value of the acceleration due to gravity into 100%, right, which is equal to 4 and pi square are constant values, so you will not find error in them, right? Obviously they are constant, so that you can eliminate. Then we have the next term, which is length. So error in length will be what? Absolute error by the actual value into 100%. Right, plus, right, again we have to add this, okay, again error when you're doing, we are trying to find the maximum error, so in all quantities you will only add the errors, right? So plus we have t square, right? So when this t square comes, this term comes to the numerator, it will become t to the power minus 2, okay? Doesn't matter, you will take the power terms outside. Remember, error when you're finding, you're only taking addition into account, because when you bring in negative sign inside, what tends to happen is the final error value reduces. What we are trying to find? Maximum possible error, okay? So we have to add, then we have 2 into, in terms of t, if we are writing, how we'll write? Very simple. What is the absolute value of time period into what is the actual value of time period into 100%. Now from the question there are 2 quantities that are given over here. Okay, what are the quantities that are given? Let me quickly write that over here. That is delta L by L into 100% is given as 2% from the question. Again, delta T by T into 100%, right? Time period of an oscillating pendulum has a value of 1%, right? 1%. So what will be the final percentage value in terms of G? Delta L by L into 100% is, this is 2% plus 2 times delta L by T. What is this? This was nothing but 1%. So this is nothing but 2% plus 2%. So the error in the final quantity will become 4%. This is the error in G. Okay. So with this we have actually done we have covered for when there is a combination of errors, when you have to add 2 terms, how to add the errors, When you're subtracting two terms, how to add the errors. When you're multiplying, dividing, or when there is a power terms, how we can actually, when we're doing error analysis, how do we handle the error in a given value. Okay. So in all cases, if you see, if it's addition or subtraction, we took it in terms of absolute errors and we added the terms, right? Error terms are always added. Now, when you did in terms of in terms of power terms, or when you are doing addition or subtraction, multiplication or division, we used fractional error, but again error terms are always added. Okay, very simple quantity. So with this we are coming towards the end of today's class. Alright, before I end the class, probably I'll do one more question. Okay, the question is, let's say you want to find the kinetic energy. Okay, you want to find the error in kinetic energy. Okay, you want to find the error in kinetic energy. So I'll write it as delta K, right? You want to find what is the error, what is the percentage error in kinetic energy. This is what we want to find, right? What is the percentage error in kinetic energy given okay, given delta, given the error in mass, percentage error in mass, right? This is basically percentage error in mass is basically nothing but in m. Okay, mass is basically percentage error in m, right? Let me just write it as m. Percentage error in m is nothing but 2%, and again percentage error in velocity is again let's say around 2% again. Okay, or let's say 2%, same value. Now percentage error in mass means what? We want to find what is percentage error in kinetic energy, and we know kinetic energy is nothing but half into m into v square. So try this by yourself as I saw, see whether you're getting the right answer. Very simple. Okay, there are two things we have to follow here. There is basically error when you're taking multiplication, and there is error when you're taking power term also. So percentage error in mass means what? Delta m by m into 100% is given as 2%. Similarly, percentage error in velocity is nothing but delta v by v into 100%. This is given as 2%. What are they asking us to find? Percentage error in K. What it means? They are asking us to find kinetic energy, right? So they are asking us to find delta K by K, okay, into 100%. This is what they are asking us to find. This will be equal to what? Half is basically a magnitude, right? It's a constant, so that doesn't apply. Next, what we have is because there is no error in mass, error in a constant quantity, right? So the next variable we have is mass. Mass will be delta m by v into 100%, right? Plus next quantity is velocity, that is delta v by v into 100%, the whole square. When we have this power term, what do? We tend to bring the power term to the base, right? This will be 2 times this value. Makes sense, right? Because it's v square means it's v times v. So those two terms also individually we need, error in those two terms also we need to add. So from here, what is delta m by m into 100%? This is 2%, plus 2 times delta v by v is basically again 2%. So this is 2% plus 4%. This gives us 6% in total. So the error in percentage error in kinetic energy will be 6%. Alright, so with this note, I am ending today's class. So there are a lot of free classes happening on the platform also, Unacademy platform also. You can actually head to the platform and register. You can follow me through the Telegram channel, or you can head to the platform again, and you can also register. You can also enroll for the upcoming free classes of this particular month. And these special classes are absolutely free, so you can join for these classes as well. Okay, so again, if you can, okay, with this note, I'm coming towards the end of today's class. So if you like the class, do share it among your friends. Also like the video. Subscribe to the channel, so before any class goes live, you would know. And also click on the bell icon to get the notification before the class goes live. Alright, I'll see you all in the next class. Have a nice day. Bye.